In this lesson, we're going to talk about how to factor completely. We're going to go over some challenging problems so that you can really master this topic. So how can we factor this expression, 3x squared plus 21x plus 30? Feel free to try that problem when you get a chance. The first thing we can do is take out the GCF. Notice that the coefficients are all multiples of 3. So let's factor out a 3. 3x squared divided by 3 is x squared. 21x divided by 3 is 7x. And 30 divided by 3 is 10. So now what we have here is a trinomial with a leading coefficient of 1. And so we could factor it by finding two numbers that multiply to 10 but add to 7. Those two numbers are going to be 5 and 2. 5 times 2 is 10. 5 plus 2 adds up to 7. So to factor it, we can write it as x plus 5 times x plus 2. And that is the answer for this problem. Now let's try another similar but slightly different problem. Let's say we have 30x squared minus 5x minus 60. Go ahead and factor this trinomial completely. So first, always see if you can take out the GCF, the greatest common factor. All of these numbers, they're divisible by 5. So let's take out a 5. 30x squared divided by 5 is 6x squared. And negative 5x divided by 5, that's going to be negative 1x. Negative 60 divided by 5 is negative 12. So now we have a trinomial where the leading coefficient is not 1. So we're going to factor this a little differently. I'm going to multiply 6 and negative 12. 6 times negative 12 is negative 72. Now I need to find two numbers that multiply to negative 72 but add to the middle coefficient, negative 1. This is going to be negative 9 and 8. So what I'm going to do is I'm going to replace negative 1x with negative 9x and positive 8x. Now at this point, we can do something called factor by grouping. So we could take out the GCF in the first two terms and the last two terms. So in the first two terms, we could take out a 3x. 6x squared divided by 3x is 2x, and negative 9x divided by 3x is negative 3. Now for the last two terms, the GCF is 4. 8x divided by 4 is 2x. Negative 12 divided by 4 is negative 3. So notice that we have two common factors here. So we're going to factor out 2x minus 3. When we take out 2x minus 3 from this term, we're left with 3x. And when we take it out of this term, we're left with positive 4. So this is the final answer. It's 5 times 2x minus 3 times 3x plus 4. So that's how we could factor this particular expression completely. Now let's move on to the next problem. So let's say we have this expression, 3y to the 5th power minus 48 times y. Go ahead and factor completely. So let's begin by taking out the GCF. The GCF is 3y. 3 and 48, they're both divisible by 3. And we could take out at least one y variable from both of those two terms. Now 3y to the 5th power divided by 3y, that's going to be y to the 4th. 5 minus 1 is 4. negative 48y divided by 3y, the y's will cancel, and so it's negative 48 divided by 3, which is negative 16. Now note what we have here. We have a difference of two squares. When you have a difference of two squares, a squared minus b squared, you could use this formula to factor it. It's a plus b times a minus b. So going from a squared to a, we need to take the square root of a squared. The square root of y to the fourth is y squared. Going from b squared to b, we need to take the square root of b squared. The square root of 16 is 4. In the first one, we're going to have a plus. In the second one, we could put a minus. Now, notice that we have a difference of two squares here, so we can factor it the same way. The square root of y squared is y. The square root of 4 is 2. One will be positive, the other will be negative. And so this is the final answer. That's how we can factor this expression completely. Now let's move on to the next problem. Let's say we have 2x to the 8th power minus 128x squared. If you want to pause the video to try it, feel free to work on this problem. So let's begin by taking out the GCF. We can take out a 2 from both of those numbers because they're both even, and we could take out the smaller of those two variables, which is going to be x squared. Now dividing these two, if we take 2x to the 8 and divide it by 2x squared, these will cancel. This becomes x to the 8 minus x squared, or 8 minus 2, and we get x to the 6. That's going to go in here. To get the next term, we need to divide those two. So if we divide negative 128x squared by 2x squared, these will cancel, and we'll get negative 64. Now what we have here is a difference of two squares. The square root of x to the 6 is x cubed. The square root of 64 is 8. So we have x cubed plus 8, x cubed minus 8. Now here we have a sum of two cubes. So we can use the formula a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. So a cubed is x cubed, b cubed is 8, which is 2 to the 3rd power. So x is a, b is 2. So a plus b, this becomes x plus 2, and then a squared, so that's x squared, minus ab, so that's minus 2 times x, and then plus b squared, or plus 2 squared, which is 4. So that's how we could factor this part. Here we have a difference of two cubes, so we could use this formula. A cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So a is x, b is 2. So this is x minus 2. A squared is x squared. And then plus ab. A is 2. A is x, b is 2, so that's 2x. And then plus b squared, or 2 squared. So this is plus 2x and then plus 4. So now we've factored the expression completely. This is as far as we can go. Now let's try this problem. 3x cubed plus 6x squared minus 12x minus 24. Go ahead and try that problem. So let's begin by taking out the GCF. All of the coefficients, they're divisible by 3. So if we take out 3, we'll be left with x cubed. 6 divided by 3 is 2. Negative 12 divided by 3 is negative 4. And negative 24 divided by 3 is negative 8. Now, notice the ratio of the coefficients for the first two terms with that for the last two terms. 2 divided by 1 is the same as negative 8 divided by negative 4. They both equal 2. When you see that, when the first two terms have the same ratio as the last two terms, you can factor by grouping. So we're going to take out the GCF in the first two terms and in the last two terms. So in the first two terms, we can take out x squared. X cubed divided by x squared is x, and 2x squared divided by x squared is positive 2. In the last two terms, we can take out negative 4 as the GCF. Negative 4x divided by negative 4 is simply positive x, and negative 8 divided by negative 4 is positive 2. So now the GCF is x plus 2. So if we factor out x plus 2 in the first term, we're left with x squared. And if we take it out in the second term, we're left with negative 4. Now here we have a difference of two squares. So we could use the formula a squared minus b squared is equal to a plus b times a minus b. The square root of x squared is x. The square root of 4 is 2. And we're going to have a plus and a minus between the x and the 2. So this is the final answer. But we can simplify this. Because these two terms are the same, we can write it once. So we can write it as 3 times x minus 2. And then we have x plus 2 written twice. So we can write that as x plus 2 squared. So this is the final answer. Now let's try this one. X squared minus 10x plus 25 minus 64y squared. What can we do for a problem that looks like that? Well, we can start with what we have here. That's a trinomial with a leading coefficient of 1. So to factor this part, we need to find two numbers that multiply to 25 but add to negative 10. So that's going to be negative 5 and negative 5. Negative 5 times negative 5 is positive 25, but they add to negative 10. So we can write this as x minus 5 times x minus 5. Keep in mind, this is a perfect square trinomial. So if you recognize that form, a squared minus 2ab plus b squared, you can write this as a minus b squared. So that's going to be x minus 5 squared. Now we have a difference of two squares. So we could use the formula a squared minus b squared is equal to a plus b times a minus b. So right now this is a squared, this is b squared. So the square root of x minus 5 squared is simply x minus 5. Now the square root of 64y squared, the square root of 64 is 8, the square root of y squared is y. So we're just going to have 8y. One is going to be plus, the other will be minus. So we could leave our answer like that because there's nothing else that we can combine. So that's it. It's x minus 5 plus 8y and x minus 5 minus 8y. For the next problem, we have 6x squared minus 7xy minus 5y squared. Go ahead and try that. So we have a trinomial where the leading coefficient is not 1. In a situation like this, you need to multiply the leading coefficient by the constant term. But that's really not the constant term though, but in this case the coefficient of the last term. So if we multiply 6 by negative 5, we're going to get negative 30. And then we need to find two numbers that multiply to negative 30 but add to the middle coefficient, negative 7. That's going to be negative 10 and 3. Negative 10 times 3 is negative 30, but negative 10 plus 3 adds up to negative 7. So what we're going to do is we're going to split the middle term into these two parts. So instead of writing negative 7xy, we're going to write positive 3xy and negative 10xy. I decided not to write this first because 10 and 5, they both contain a nice number, 5. They're both multiples of 5. I wanted to put the 3 next to 6 because 6 and 3, they're both multiples of 3. Because at this point, we need to factor by grouping. So in the first two terms, it's easy to take out the GCF, which is 3x. 6x squared divided by 3x is 2x. 3xy divided by 3x is simply y. Now let's take out the GCF in the last two terms. This is going to be negative 5y. So negative 10xy divided by negative 5y. Negative 10 divided by negative 5 is positive 2. The y's will cancel, leaving behind the x. So it's just 2x. Negative 5y squared divided by negative 5y, that's going to be positive y. So now we have another common factor, which is 2x plus y. And then we're going to get 3x and negative 5y in the second set of parentheses. So this is the final answer, 2x plus y times 3x minus 5y. Now let's try this problem. X squared times x minus 2 minus 3x times x minus 2 minus 18 times x minus 2. So what would you do if you were to see a problem like that? This problem may appear complicated, but it's not when you think about it in principle. We have a common factor, x minus 2. So like always, we should take out the GCF. If we take out x minus 2, in the first term, we're left with x squared. In the second term, negative 3x, and in the third term, negative 18. So now we have a trinomial with a leading coefficient of 1. So we got to find two numbers that multiply to negative 18, but add to negative 3. So that's going to be negative 6 and positive 3. So the factor of this trinomial is simply going to be x minus 6 times x plus 3. And that is the final answer for this problem. So it looked complicated initially, but it turned out that that problem wasn't that bad. Now, what would you do if you were given a problem that looks like this? Y times 2x plus 5 raised to the 1/2 minus 3 times 2x plus 5 raised to the 3/2. So what we need to do is take out the GCF. It's going to be the smaller of these two. 1/2 is less than 3/2. So we're going to take out 2x plus 5 raised to the 1/2. Once we take that out, we're left with a y here. Now, if we were to divide these two, what will we get? Well, we have a -3 in front. Now, when dividing these two, we need to subtract the exponents. So it becomes 2x plus 5 raised to the 3/2 minus 1/2. 3/2 minus 1/2 is 2/2, and 2/2 is 1. So this is simply, let's fix that. This is -3 times 2x plus 5 raised to the first power, which we could just simply leave it like this. Now, when something is raised to the 1/2, it's the same as being inside of a square root. So we can leave this as the square root of 2x plus 5. Now, we can leave it like this, or we could distribute the -3. I'm going to distribute the -3. So it becomes y minus 6x minus 15. So that is the final answer for this problem. Now let's move on to the final example. X squared times x plus 3 raised to the -2, and then minus 4 times x plus 3 raised to the -1. Try that problem. So let's begin by taking out the GCF. Is the GCF going to be x plus 3 raised to the -2 or x plus 3 raised to the -1? It's going to be the smaller of the two. Which one has a lower value on the number line, -2 or -1? The answer is -2. -2 is less than -1. So for the GCF, we're going to factor out x plus 3 raised to the -2. And we're going to be left with x squared. Now what about this one? If we factor out x plus 3 raised to -2 from this, what do we get? To find it, divide this by the GCF. So let's work that out. So first, we're going to get a -4, and then we're going to subtract the top exponent by the bottom exponent. So it's -1 minus -2, which is -1 plus 2. -1 plus 2 is +1. So we simply get -4 times x plus 3. That's why it's good to take out the smaller of the two factors. It works out nicely when you do it that way. Now, x plus 3 raised to the -2, that's the same as 1 over x plus 3 squared. Now I'm going to distribute the -4, so it becomes -4x minus 12. Now we have a trinomial with a leading coefficient of 1, so we need to find two numbers that multiply to -12, but add to -4. So -6 and +2. -6 times 2 is -12, but -6 plus 2 is -4. So we can write this as x minus 6 times x plus 2. So our final answer is x minus 6 times x plus 2 divided by x plus 3 squared. So that's how we could factor an expression with negative exponents.